Swayam Prabha. Digital India. Educated India.
Hello everyone. Now we will continue with the evenness testing of fibrous mass, and we were discussing that addition and reduction of CV%. So in the numerical which we have already discussed, where the CV percentage was reduced by doubling a number of slivers, and then it was added, CV% was added by drawing. So to continue with this, our next numerical is that the mass CV of card sliver is 6%. Number of doubling at the draw frame is 8. If the mass CV added at the draw frame is 5% and added in the roving frame, it's again 5%. So what will be the product of the roving frame? That is roving. Now you can see here, this is draw frame and speed frame or roving frame. Or roving frame, and then we are getting product is now as per the given condition. So 8 card slivers are fed in the draw frame. It's a single passage draw frame, okay, drawing process. So 8 card slivers are fed, where each card sliver is of 6% CV of card sliver. Now the next condition is that the draw frame adds CV of 5% and speed frame adds CV of again 5%. Now first, as we have discussed, first we have to see the input CV of input mass, that is 8 slivers together. CV of 8 slivers will be individual sliver, this is 6% divided by under root 8. So this will become 6 divided by under root 8. We can 6 divided by under root 8 will be the value 2.12. 2.12 is the CV. So CV of individual is 6. Now this mass 2.12 is the 8 slivers. Then we are adding 5%. So here CV of draw frame sliver will be under root, it is added, so 2.12 square, which is input mass, and 5% which is added. So it will become 5.4243. So 5.43 is the CV of drop frame sliver. Again 5% CV is added at the speed frame or roving frame stage. So CV of roving finally will be 5.43 square plus 5 square. So it will be 7.38. So this is the answer here, 7.38. Okay. So in this way we can solve this numerical. So let us see. 8 cut sliver, 6% as we have discussed. So the input material at the drop. It's not the sliver form, it's a in a mass form, 8 slivers to, and then it is added 5.431, and again 5% is added at the roving frame. So finally we get 7.38. So in this way we can solve the problem. The idea is that we have to understand the point where the CV percent is added, and we should know the flow of material in the spinning process. Next numerical is the following particular short staple spinning line producing 20 tex yarn from 200 millitex pipe. So 200 millitex means 0.2 tex. 0.2 tex fiber, and the yarn tex is 20 by 0.2. Number of fibers in the cross section will be cross section of the yarn, that is yarn tex by fibers. So number of fibers in the yarn is this, and then the story is that mass CV of card sliver, that is card sliver, is 4%, carding sliver, and number of doubling at the drop frame is 6. So 1, 2, 3, 4, 5, 6. 6 drawing card slivers are added. So each of 4%. Then the drop frame adds 3%. This is drop frame, which adds 3%, okay, of the CV unevenness. Then we get drop frame slide. This drop frame sliver again is drafted at the drafted at the roving frame to produce roving. So this draw frame sliver is drafted at the roving frame like earlier, where roving adds plus 4%, and then it is again drafted at ring frame which adds 8%. So ring frame adds little bit higher than a roving frame because the ring frame draft is generally more than roving frame, although there are different fiber control mechanism, but as the draft is more, so generally ring frame adds more unevenness, and number of passage of draw frame is 1. So this is the story. So mass CV of roving and index of irregularity of yarn. So mass CV of roving we can calculate like earlier numerical. So the draw frame slivers CV will be 4 multiplied by, so more 4 by under root 6. Okay, that is the input material. This is the input material will be 1.63%. This is the input, and then 3% is added. So under root 1.63 square by 3 square, which will be the draw frame sliver 3.41%. So 3.41% is the CV of draw frame sliver. Draw frame sliver, and then roving is adding 4%, further 4%. So CV of roving will be under root 3.41% square plus 4 square. 3.4 square 41%, it will come out to be 5.25. So that we can observe that gradually the CV% is increasing. This is the 5.25%. Okay. Now CV% of yarn, again the same formula, 5.25 square by 8% is added. It will become 9.57. The 9.57% is the CV of yarn. So mass CV of roving is 5.25. So 5.25 is the mass CV of roving which was asked, and CV of yarn we have got. CV of yarn, and next it is asked that what will be the index of irregularity of ring frame where yarn is being formed. We want to know the index of irregularity. So index of irregularity, if you want to calculate, you have to calculate the limit irregularity, CV limit irregularity, and CV limit irregularity is, this is a short staple fiber, polyester fiber. As it is polyester, it will be 100 by under root n. So it will be 100 by under root 100. So it will be 10 fibers. 10% is the CV limit. Now I think this numerical we have to see carefully. The CV limit, what we see, it's added. So mass CV of roving is 3 point output of roving, and this is the roving output. Let us see some 3 point. Oh, that okay. Now 6 card slivers were there with CV of each sliver is 4. So up it's doubled. We get 1.632%, and then added again 3%. So we get 3.415%, and mass CV of roving after adding again 4% at the roving stage. So it is coming out to be 5.26% that we have seen earlier. Then %8 was there. So the index of irregularity, this is CV limit. I think let us see. So CV added in ring frame is 8%. So CV of yarn is 9.57, and yarn cross section 100. So CV limit is 10. I think there is some problem with the data, but actual, if you see the as per the logic, CV limit is 0.957. Now this is not possible because index of irregularity cannot be less than 1. So in our assumption, so this assumption is cannot be true. So this all these assumptions cannot be true here, because you see here with all these assumptions, some of the assumptions may be wrong. Here either addition will be more somewhere, or number of fibers will be say less, so that we must get CV actual must be more than CV limit, so that we get index of irregularity less than 1. Index or so if we get this type of data, we have to see whether we are getting all the correct data or not. In case we get index of irregularity less than 1, that means the data which you have got is not, these are not correct. Either one particular data will be missing, wrong data will be there. So let us see how to see what will be the wrong data, which could be the wrong data. If we consider the addition in at each stage are constant or same, because we have our experience says this card adds 4%, drop frame adds 3%, roving frame adds 4%, ring frame adds 6%. That is our experience. So we can consider this is correct. Then our takes of the yarn which we are producing, that may be correct. Then some problem may be with the millitex. So we have considered this as millitex is. So what is limit irregularity? Limit irregularity is 100 by under root n. So 100 by under root n. So that means if we increase the number of fibers, then in the yarn cross section, then limit irregularity can be increased. So CB actual in our present condition is correct. So CB actual is correct. So CB limit should be less than the CB actual. So CB limit to be lower, that means our number of fibers should be more. So this fiber millitex should be little bit lower. So let us consider another case where we are using say 100 millitex. In this present situation, the fibers are of 100 millitex. This fiber should be definitely it's finer than 200 millitex. So 100 millitex fiber, if we see, that means takes of the fiber would be 0.1 and number of fibers in the yarn n will be 20 by 0.1, so it will be 200. So CB limit will be 100 by under root 200. So the value will be 7.07. So this cannot be there because we have seen the CB, that index of irregularity should be more than 1. Okay. So here which we have got, as per the definition, index of irregularity must be more than 1, but which we have got, it was less than 1. So now if we consider this 7.07 in our calculation, so we can get the value 7.07 and 9.57 is the output here. So 9.57 divided by 7.07, 1.3. So we have seen that the number of fibers here, it should be 0.1 is would be the text, so it should be 200. Anyhow, this value number of fibers should be such that at least this CB limit should be more than less than, this should be less than 9.57, so that we can get the value of index of irregularity more than 1. Okay. Now next numerical, there is a table given. This is the table given which gives the relevant processing details. Produce 25 tex yarn from 0.5 tex man-made fiber. So man-made fiber tex is 0.5 tex and 25 tex is produced. So in yarn, here you can see the number of fibers in the yarn cross section is 25 by 0.5. So 50 fibers. And here the draft given in the ring frame is 14 and CV percent of the yarn is 15.9. Roving frame, third draw frame, second draw frame. So three stage draw frame is given. Now what is asked? Been asked, calculate the index of irregularity, addition of irregularity in ring spinning, roving frame and third draw. So let us go one by one. This type of numerical where we know the number of fibers at certain stage. So if we know the number of fibers at the first draw frame stage, then we should go start with the first draw. Here we know the number of fibers in the ring spinning system. So that's why we'll start from the ring spinning and then go gradually back. Okay. Now first start with the ring spinning. So in ring frame, number of fibers are 50 from the given relationship, and we know the relationship for, so CV limit can be calculated 100 by under root 50. This is the CV limit. So CV limit is 14.14. So 14.14 is the CV limit, and now for yarn we can go back. CV is 14.1. Sorry, I think this will be 15.9. No, sorry, 15.9 was the 15.9, right? 15.9 was the CV percent. Okay, draft was 14.1. So limiting CV is 1.12. Now another question was that addition of CV irregularity at the ring frame. Now we know the CV percentage of yarn and CV percentage of roving. So CV percent added in ring frame will be square of under root square of CV percentage of yarn that is 15.9 minus square of CV percentage of roving. So roving is 6.5. So if we see 14.51 is the CV% of CV% added at the ring frame. Next is the roving frame. Now as per the table, the draft at the ring frame was 14.1. Draft is given, so that was from the table. Draft is given, it's 14.1. So from the draft we can calculate the linear density of roving. We multiply with the yarn linear density, so 352.5. So we can calculate the number of fibers in the roving. So it will be 14.1 times of the number of fibers in the yarn. So this is 705, and then again we have to calculate the limit irregularity of roving. Will be again 100 by under root 705, which will become 3.76. So limit irregularity we have calculated, and we know the CV of roving, which is given. CV percentage of roving is 6.5 was given. So the ratio will be the index of irregularity of roving. So CV percent we can refer to the earlier table. So this is 6.5%. Okay. Then the input material here is third drop frame sliver. So you want, now we have to calculate the addition of the CV. So third drop frame sliver was the input material, and CV output of the roving is given 4.5%, so 6.5% in the roving, and so that addition we can calculate by this formula, under root 6.5% minus 4.5%, which has become 4.6. So this is the addition of the irregularity at the roving frame. Now let us come to the third drop frame stage. At third drop frame stage, third drop frame sliver linear density equal to roving linear density multiplied by, this is in text, multiplied by draft in roving frame. So from there we can correct. So draft in roving frame as per the table, it's 10, and roving linear density we have calculated earlier, so it will become 3525 ticks, and number of fibers will be 10 times of the roving fibers in the roving, so it will become 7050. In roving it was 705, and the limit irregularity, same formula, it's 1.19, and we know the irregularity as per the table, it was 4.5. As per the table, the irregularity of the third drop frame slide 4.5 and the limit irregularity is 1.19. We get the index of irregularity as 3.78. So we can see here the performance. If we compare the performance of overall performance of between the third drop frame to roving, so third drop frame performance is very poor. Okay. And then we have to see the addition of irregularity. Now here the second drop frame sliver irregularity was given 2.8 and number of drawing in the third drop frame was 2 as per the table. So input materials, the CV percent is 1.98 and CV percent of the output, that is output material, that is sliver, it is given in the table 4.5. So CV added will be 4.5% minus 1.98, 4.5 square minus 1.98 square under root, it will be 4.04%. So you will see the CV addition is all here 4.04%. So in this way we can solve this type of problems where addition or reduction of uniformity are there. Now similar problem, let us see. A 3.5 kilotex finisher drop frame sliver produced from 100% wool fiber of average diameter 20 micron. And coefficient of friction, sorry, coefficient of variation is 2%. So micron is given average diameter and diameter variation is 2%. The same sliver is converted to 150 tex to roving and then yarn of 30 tex. Assuming the wool fiber linear density is 1.3 gram per cc and standard deviation of fiber diameter to be 5 micron. 5 micron is the standard deviation of fiber. This is the CV of mass. Mass CV is 2%. The standard deviation of diameter is given and index of irregularity. The index of irregularity of finisher drop frame sliver for drop frame, roving frame and ring frame to be same. This is the condition. The important condition here, the index of irregularity in all the condition machine to be same. Then you have to calculate the irregularity added, extent of irregularity added at roving frame and ring frame. So this problem we have to address one by one. Here mass CV percent is 2%. Now let us see. Standard deviation is given here. So we know the average diameter of fiber is given 20 micron and standard deviation of fiber diameter. So this is given, its fiber diameter is 5. So from there we can calculate the CV percentage of fiber diameter So wool fiber density is 1.3 gram per cc. Now fiber linear density we can calculate if we know the fiber diameter and the density. So from earlier formula we can calculate this is the fiber linear density of wool in decitex. So using the relationship we have discussed in fiber fineness and coefficient of variation of fiber diameter Vd is calculated. The standard deviation is given and this is the mean diameter. So it is 20%, 20 micron was the mean diameter. So 25% is the CV of diameter. From there we can calculate the limit irregularity using the relationship which has been discussed earlier. So limit irregularity will be using this relationship where VRW is the of wool limit irregularity. So this is the wool fiber limit irregularity, and then N is the number of fibers and Vd is the coefficient of variation, variation in fiber diameter Vd. So we have this data, Vd is with us, so we have to calculate the N, number of fibers in the cross section. So we know the fiber linear density and we have the yarn linear density given. So from there if we solve this numerical, so we will get 111.8 by under root n. So n is the number of fibers. So the sliver text is given number of fibers in the finisher dropem. First let us calculate the number of fibers in the finisher dropem. So this is the finisher dropem. So 3.5 kilotex is the finisher dropem. So we can calculate the number of fibers text of the dropem sliver, and this is the point, this is the decitex, and we can calculate, we can convert it to 0.4082 tex. So this tex is used. So here we have fiber number of fiber 8574. So approximately 8574 fibers are there in the sliver cross section. So we can calculate the limit CV of drop frame sliver. So this will be 1.20. So n being 8.8574.2. So we can calculate the limit irregularity 1.2. So the question which was asked is index of irregularity. Index of irregularity, and the condition was that the index of irregularity for all these processes are same. So calculate the extent of irregularity added. So first we have to calculate the index of irregularity. So this is limit irregularity you have seen 1.2, and CV% of draw frame sliver, which is given 2%. In the numerical, CV% is given 2%. So we can calculate the index of irregularity 2 by 1.2. So it has become 1.66. Now, this index of irregularity, as per the condition, this index of irregularity will be equal to the index of irregularity of roving frame and index of irregularity of ring frame. That is the condition. And this we will be using as per the given condition. So there, roving frame equal to irregularity ring frame equal to 1.66. Now, number of fibers in the roving text by fiber text. Roving text is given 150 text and fiber text of 367.4 is the number of fibers in the roving. So roving text is given, so 150 text, and yarn text is given 30 text. So in the numerical, so 150 is there. So limit irregularity of roving is this relationship we have got from the diameter variability 111.8, and this is the number of fibers in the cross section. So the limit irregularity is 5.83. So this same relationship will be valid because as we are using the same fiber, 111.8 by under root number of fibers. So limit irregularity is calculated, and then index of irregularity equal to CV of roving by limit irregularity equal to 1.66, that we have seen. Now from here we can calculate the CV of roving, CV output of roving. So CV of roving is 9. CV of roving, limit irregularity we have calculated already. So 9.69 is the percent is the roving output. Now roving output, so this is the roving frame, and here roving frame, the input CV of draw frame sliver is 2%, and CV of roving is 9.69%. So from there we can calculate the CV added by the roving frame. So CV of roving, so number of fibers in the yarn is yarn text by fiber text. Yarn text is given, so number of fiber in the cross section here. So limit irregularity we can calculate of yarn is 13.04 from the same relationship. So index of irregularity of ring frame CV of yarn by limit irregularity. Limit irregularity we have already calculated. So in limit irregularity we have calculated 13.04, and index of irregularity was 1.66, and CV of yarn is 21.64. So what we have done till now, we have calculated the CV of roving. CV of roving we have calculated 9.69, and we have calculated the CV of yarn. So from there we can calculate the extent of irregularity added at roving. So input of roving was the drop frame sliver, which was 2%, and roving was 9.69% we have calculated. So 9.48% was the CB added at the roving frame. And for yarn, that is CB of roving is 9.69 and CB of yarn is 21%. So from there we can calculate the addition at the ring frame stage. So 21.64 square, which is in the yarn, and 9.69 square, which is for the roving. So we can get 19.36% the addition in ring frame. So if we have clear conception about the definition and what is index of irregularity, what's the process flow where the draft is being imparted, so how to calculate the number of fibers, we can address all these types of numerical. Okay. Now next numerical is the mass CB percent of card sliver is 4%. Number of doubling at the drop frame is 6. If the mass CB percent added at drop frame is 3%, added in speed frame 3%, then mass CB of roving. So this type of numerical we have already done, so we will not discuss in detail. So input material is 4 by number of sliver, so 1.632%. So CB% added at drop frame is 3%. So output of drop frame, that means drop frame sliver CB% will be 1.632 square plus 3 square under root. It will become 3.41%. Again, CB% added at the roving frame is 3%. So mass CB% in output roving will be, using the same relationship, it will become 4.54%. The next numerical is the mass CB of card sliver is 6%. Number of doubling at drop frame is 6. The mass CB added, it's 4%, added in drop frame 4%, roving is 6%, and added in ring frame is 4.5%. So mass CB of yarn, the similar problem, but here we want to know the yarn CB. So stepwise same. So mass CB of input of drop frame 6 by under root 6, because 6 doubling and 6% card sliver 2.44. Then mass CB of output of drop frame, this is drop frame sliver, so it will be 2.44 square by plus 4 square under root, it will become 4.68. Then mass CB of speed frame, that is roving, so CB input of speed frame means output of draw frame, that is draw frame sliver, and added its speed frame. So draw frame sliver was 4.68 and added at speed frame is 6%. 6% is roving frame. So it is the roving becomes 7.60. Similarly, we can calculate the CV of yarn, that is CV of roving square plus CV added at ring frame. So 8.83 is the answer. Next is that consider the following particulars for a short staple spinning line producing 25 ticks yarn from 100 millitex polyester. So 25 ticks yarn from 100 millitex polyester fiber. So number of fiber in the yarn cross section will be 25 and millitex. 100 millitex means 0.1 ticks. Okay, 0. So it will become 250 fibers in the yarn. So n equal to 2, n equal to n in the yarn will be 250. So mass CV of card is 3%. Mass CV added at draw frame is 2%. Mass CV added at roving frame is 3%. Mass CV added at ring frame is 7%. Number of doubling 8%. Number of draw frame passage 1. Calculate the mass CV of roving and index of irregularity of yarn. So this type of numerical we have already discussed. So we will try to see the steps. So mass CV of input, 8 is the doubling given and 3 is the card sliver, 3%. So it is 1.06%. This is the input of the 8 sliver. Input 8 sliver, and then the mass CV of output of the draw frame. So if we know the addition, so addition is given 2%. If we know the addition, then we can calculate the mass CV of the draw frame slider, and then mass CV at the output of speed frame, so that means roving frame. So mass CV added at the roving frame is 3%. Then mass CV input at speed frame, that is roving frame, which is the output of draw frame. So from there we can calculate the mass CV output of the speed frame, that means roving. Roving, this is roving CV $3.758. Now index of irregularity of yarn, mass CV output of at a ring frame, you have to calculate. So mass CV added, CV% added at ring frame 7%, and CV% of roving was given, you have calculated. So that is the input of ring frame, which is roving 3.758, that we have already seen, 3.758, and we can calculate. So CV of yarn. So mass CV of yarn, roving, then added roving CV is 3.758 and 7% is added. So we are getting 7.945 CV% of yarn. The CV percentage of yarn we have calculated, and what we have to calculate, the CV limit. CV limit, if you want to calculate, we have to calculate the number of fibers. The number of fibers we have already seen earlier. From the yarn text and fiber text, we have calculated 250 is the number of fiber. The CV limit will be 100 by under root 250. CV limit 100 by under root 250 is 6.32. So that is the minimum. Best performing machine will produce 6.32, but actual yarn is 7.945. So index of irregularity which is asked for, 7.945 divided by 6.32. This will become 1.25. So that is actually 256. So this way we can calculate the index of irregularity of yarn. Now let us see another numerical. So what are the particulars here? Consider the following particulars for a short staple spinning line producing 30 text yarn from 100 millitex polyester fiber. So in yarn, number of fiber in the yarn, 30 divided by 0.1 text, 100 millitex equal 0.1 text, 300 fibers. Number of fibers in the yarn cross section. Mass CV of card sliver is 4%. Mass CV added at draw frame is 2%. So mass CV added at roving frame 2%. Mass CV added at ring frame 5%. Number of doubling at draw frame 8. So these are the conditions given. So CV% of roving we have to calculate, index of irregularity of ring frame. So the similar way we will continue. CV of draw frame, input draw frame is card sliver input of 8 card sliver. So one card sliver is having 4% by under root 8. So this will be the 8 card slivers on this square plus added at the draw frame 2.5%. So this if we take whole, then the CV% of draw frame will. So we can see 4 by under root 8 will be 1.41 and this will be 2.5%. We will get 2.872%, which is CV% of draw frame output, because in the draw frame, at the back of the draw frame, we feed 8 card slides and draw frame passage 1. So there is no issue. Next is the mass CV added at speed frame is given, that is roving frame is given 2%. So this is input of roving frame 2.872 and added 2%. So mass CV of roving speed frame output, that is roving, using the same relationship we will get 3.5%. Okay. Now there is this is CV of this plus 2% added, it will be under root 17.25, it will be 4.3 point, no, under root 17, no, okay, this will be 12.25, sorry, this will become 12.25. So if we add this, it is 12.25, so it will be 3.5%. So we can get the CV of roving. Then next step is that index of irregularity of yarn. So for that we have to calculate the CV output of ring frame, that is yarn CV, actual yarn CV. And when we know the CV added in ring frame and we know the mass CV of roving, so we can calculate the CV output of yarn. So yarn CV, this is the yarn CV %. And we can calculate the limit CV. So limit CV is, N is the number of fibers that we have already calculated, 300. So limit CV is 5.7, as it is man-made fiber. And from there we can calculate the index of irregularity to be 1.05, 6.103 by 5.77. So this type of problems can be solved. So first main issue is that we have to calculate the number of fibers at any point of time. In any of the stages we must calculate the number of fibers. So to know the number of fibers, we must know the linear density of fibers. Now there is a table given. This is the table given, which gives the relevant processing details used in the production of 36 tex yarn spun from 152 mm 0.5 tex man-made fiber. So length of fiber we don't take into consideration during this type of numerical when we are dealing with the CV % and the index of irregularity. So we only take into consideration the number of fibers in the cross section. So 0.5 tex man-made fiber. So if we see the ring frame, number of fibers in here will be 36 divided by 0.5. So 72 fibers will be in the yarn cross section. And so if we know the number of fibers here, we can calculate the limit irregularity, and we know the CV % here in the ring frame. So we can calculate the index of irregularity here. So what you have to calculate? Calculate the index of irregularity and addition of irregularity in all these stages. So the the similar problem we have already done, but with a different data. We will just go quickly. Yarn count linear density is given 36 ticks. Fiber linear density 0.5. So number of fibers in the cross section is 72. And as the fiber type is man-made fiber, so we use this relationship for limit irregularity 100 by under root n. So limit irregularity of ring frame of yarn will be 11.78, and index of irregularity of ring frame is 1.26. And now the CB of roving material is given 7.5 roving, and CB output of yarn is given, and so CB added is you can calculate at the ring frame. CB added at the ring frame stage. Next is the roving stage you have to calculate. The roving linear density is draft is 14.1 at the ring frame. So linear density will be 507.6 ticks. So fiber number of fibers in the cross section will be 1015, and from there we can calculate the limit irregularity, which is 3.13, and index of irregularity is 2.39, and here CV input material, which is yarn CV, was 5.5. So that we can see here from the table. Okay. The CV of yarn, the CV of third drop in 5.5, you can see. So CV input means input in roving means the output in third drop in 5.5. So CV of output material is, we know that for roving it is 7.5. So we can calculate the addition at the roving using the standard relationship. So addition of irregularity at roving frame will be 5.1%. So hard drop frame sliver count will be, when draft is 10 at the roving frame, so third drop frame sliver will be 5076, and the number of fibers in the cross section is 10,152, and limit irregularity is 0.99, and index of irregularity we can calculate, it's 5.55. So 5.5 is the irregularity of the sliver, and as the number of input material at the third drop in is 2, is a doubling, and 22.8 was the CV of sliver, input sliver. So this is the total input material. So 2 slivers when we are feeding, so take second drop in sliver, 2 slivers were feeding, so input material at third drop in is 1.979, and output is 5.5, and we can say the addition of irregularity is 5.18. So we can see from the table. So third draw frame output is 5.5 and input is 2.8. So here number of doubling was 2. So from there, this data we can calculate. So 2.8 divided by under root 2. So here we can calculate the addition of irregularity at the third drop. So which was asked. Now next numerical is CV% of 4-ply yarn produced from a single yarn having CV of 10.8. So this is very simple. 10.24. So 10.24 is the individual. So 4-ply is then under root 4. So the CV% will be of 4-ply yarn will be 5.14. So 10.2%. 10.24, 5.1. 5.12 is the. So we can solve different types of numerical. So what we have done till now, we have tried to see at different stages how to calculate the number of fibers, how to calculate the index of irregularity. Index of irregularity is which is a factor which shows the performance of machine. Now we will stop here. In the next class we will discuss the further aspects of yarn irregularity or irregularity of fiber mass. Till then, thank you.